practicing factoring, and at the bottom we're going to be practicing factoring and then splitting and solving. So which one would you guys like to see?
6 and 14.
6 and 14. Okay. You're always supposed to try to factor out the GCF on any of these. Now, if we look at number 6, there's not two terms or 3 terms. There's actually 4 terms. And most of the time that we have 4 terms, obviously we got to start by seeing is there anything in common in all 4 terms? No. But you do realize that there's something in common in the first 2, and there's something in common in the second 2, right? So what method are we going to be using? Factoring by grouping, right? So if you look at the first group, what's in common in the first group? An A and also the multiple of 2. So the GCF in the first group would be to pull out a 2A. Maybe to make it a little more clear, let me make some space between the first 2 terms and the second 2 terms, separating them into 2 groups. Now we said in the first group we're going to pull out 2 and an A, so we're pulling out 2A. What would be left in the first group if we pull out a 2A? Okay, minus 3. Okay, the second group, is there anything to pull out? No, but because we're attempting to factor by grouping, we're going to pretend that we're pulling something out which is kind of irrelevant, but we're pulling out an invisible 1. Okay, so let's pull out a positive 1. But when you pull out a positive 1, it really doesn't do anything to your k or your minus 3. Actually, let me put this parenthesis in red. And you still have your k and your minus 3. Pull out a 1, nothing changes. But we still pull out a 1 so we could see that in the first group, in parentheses, we have a k minus 3. In the second group, in parentheses, we have a k minus 3. So what are we going to pull out from both groups? K minus 3. We're going to pull them out. So let me zoom out a little. And I want to pull out the k minus 3s and put them out here in the front. That's what I did right now. I took this k minus 3 and this k minus 3 and pulled them out here in the front. Now, if I did do that, what would be left on the inside? Well, the 2a would come straight down. So this 2a right here is going to come straight down, 2a. And this plus 1 is going to come straight down, so it's a plus 1 right here. Now, obviously, we have some exaggerated parentheses. Let's just write them in the right size, and we're done. And there's your final answer. And that answer makes Jonathan happy. Which other questions? 14? Number 14. It's kind of tricky. We need to become very familiar with the difference of 2 squares, right? Before we even look at number 14, let me just go to the side over here, and let me ask you this. Does everybody know how to factor x squared minus 9? That becomes parentheses, and we put an x right here and an x right here because x times x is x squared. But what happens with the other numbers? Plus 3 and minus 3, right? Because a positive 3 times a negative 3 is the negative 9 that we have over here. And if you add positive 3 and negative 3 together, it really does give you 0, which is the middle term. There is no middle term. You guys understand that? Okay, now what if we had x squared minus 1? Then what would it factor to?
X plus 1, x minus 1.
There you go. X plus 1, x minus 1. That's not difficult to do, right? Once again, you think, what times what is negative 1? That if you add together is nothing, right? That's a positive 1 and a negative 1. And the x's are easy because x times x is x squared. So if you understand that, you should be able to do this other one, m to the 4th power minus 1, in the same exact way. So what am I talking about? You do the parentheses, but instead of m times m, that's not going to give you an m to the 4th. What are we going to put instead of m's? M times m is m squared. So we want m squared times m squared, right? Because that'll get us the m to the 4th. And then you just think the same process. What times what is negative 1 that if you add together is nothing? A negative 1 and a positive 1, correct? Yeah? Okay? So now, when you factor, you're always supposed to look at the inside of your parentheses and see if you could continue factoring. Now, once again, you have an m squared minus 1. Maybe you'll be able to do an m here and an m there and continue factoring. Are you able to do that with this first one right here, m squared minus 1? Yeah, what times what is negative 1 that if you add together is nothing? Again, a negative 1 and a positive 1. Okay, and maybe over here, the m squared plus 1, you'll be able to keep going, m times m. What times what is 1 that if you add together is nothing?
Can't do that.
It doesn't work, because 1 times 1 is 1, or negative 1 times negative 1 is 1, but neither of those cancel out to give you nothing in the middle. So this cannot be factored, so I need to erase it. In other words, m squared plus 1 is as far as it goes. It can't be factored. So I just bring that down, m squared plus 1. So when they ask you to write it in factored form, this would be it. There's nothing else to factor. Now again, why are we practicing factoring? Because at some point, or we've already done it, but you will have like an equals 0, right? And then you have an equals 0 here, and then you'd be able to split each one of them. M minus 1 equals 0, m plus 1 equals 0, m squared plus 1 equals 0, and you'd have to solve all three equations. Oh, x, m, not x. But see, this wasn't even an equal 0 to start with, so I'm just saying that's why we're factoring, to be able to practice for the future when we're actually solving equations. But this is not even an equation, it's just an expression. Any other ones? Huh? Jumping to number 24, what could we factor out? Always try to pull out a GCF first. B. So let's pull out a B. What's going to be left on the inside? Of course, this is an equation that we need to solve. But what's going to be left on the inside? B squared minus 8b plus 16. All right. Now, on the inside of the parentheses, talking about this quadratic trinomial, could that be factored further? Now, let's say it weren't. Let's say you couldn't factor it further. What would you do? You would use the quadratic formula. You'd have to split it. This one would be b equals to 0, and then you would go this one equals to 0. So you'd be able to get the b equals to 0, but this guy you'd have to use a quadratic formula. But luckily, this b, you're just going to bring it down, and this quadratic trinomial, we're going to be able to factor it further to b, and what times what is 16 that if you add together is negative 8? What times what is positive 16 that if you combine gives you negative 8? Negative 4, negative 4. So it's completely factored. We took this cubic trinomial and we completely factored it. We rewrote it to become b times b minus 4 times b minus 4 equals 0. So we need to solve this thing because it is an equation after all. So when you have it equal to 0, you're able to split this one equal to 0, that one equal to 0, and this one equal to 0. So you're going to have one equation that says b equals 0, the other equation that says b minus 4 equals 0, and the other equation that says b minus 4 equals 0. Now the first equation, it's already solved for you. That's an answer, b equals 0. The next equation is b equals 4 if you add 4 to both sides. And the last one's a duplicate, b equals 4 also. Okay? So this cubic equation really does have 3 answers because it has a power of 3, so it has 3 real roots, or 3 answers in this case, but one of the answers is duplicated. So you're not going to really write it twice, you're just going to write down the 0 and the 4. Now visually, this would be a graph that crosses the x-axis at 2 locations, the 0 and the 4. Make sense? Okay. 13, going back to factoring, not solving. This is just the difference of 2 cubes, right? We should know the difference of 2 cubes formula. That's a difference of 2 cubes formula right there. I wrote it like this to help you remember that you need to write in parentheses cubed on the outside, write it in parentheses cubed on the outside, so you could identify your a and your b value. And then once you know your a and your b value, then you could use this formula, just plug in your numbers. So for example, you can't say that a is n and b is 125. That would be incorrect. First thing to do is to write it as parenthesis cubed minus parenthesis cubed, And in the first one, you have an n, because n to the third power will be n to the third power. And in the second parentheses, what are you going to have? Anybody? 5. Why? Because 5 times 5 is 25 times 5, that's 125. So it's essential that you do this part, even though this is not part of your answer, this is not part of your formula, this is just to be able to identify your A value and your B value, which A is right here, B is right here. And now you could use your formula, the binomial times the trinomial, okay? So now you know your A and B. So your binomial that goes right here is going to be the exact binomial without the cubes, which is n and a minus 5. So you're going to have n and a minus 5. Your trinomial is a little bit more challenging. I recommend you use parentheses. So as you go along and go a squared, ab, b squared, use parentheses. So instead of a squared, go parentheses squared plus ab plus parentheses parentheses plus b squared parentheses squared. And then plug in your a and your b value, which is an n, and a 5, and a 5. And then you just simplify it. N minus 5, n squared plus 5n plus 25. If you check the back of your worksheet, that's your answer for that one.